Hello there, Charger family. This is Mrs. Boyd at Mrs. Boyd's Math Room. Today we're going to be talking about really generally rectangles and all the things you don't and already know about rectangles. Let's go ahead and talk about the nitty-gritty, the details about rectangles that make them what they are. So a rectangle is a parallelogram with 4 right angles. It's the biggest generality, as well as, and here's the details of the things you need to know. Opposite sides are parallel and congruent. So sides across from each other are the same length and never cross. Number 2, opposite sides are congruent. Oh, opposite angles, crap. I wrote sides again. And I meant to write angles. Opposite angles are congruent and all measure 90 degrees. So they're all right angles. Number 3, consecutive angles are supplementary. This makes sense because if they're all 90-degree angles, when you add 90 and 90 together, that gives you 180, which means they're supplementary. Number 4, diagonals bisect each other. So when diagonals cross, that means this splits the diagonals in half. Last but not least, diagonals are congruent. That means diagonals, no matter which vertex they come from, are the same length. Let's put these principles into some computational math where we solve some things. Let's take a look at this rectangle. It says quadrilateral ABCD is a rectangle. Obviously, I just said it. If the measure of angle ACD, well, ACD is going to be this angle right here, and that angle is 5x plus 1. And the measure of DBC is this angle right here, is 6x plus 1. Well, this wants us to find x. So here's what we're going to say. We're going to say that, I'm going to name this center point E. And I'm going to say that triangle BCE is a isosceles triangle. So these two lengths are congruent. So that means these two angles are congruent. So I can say that this angle is also 6x plus 1. Now, I want you to forget that this one up here, if we can erase it, cannot. Let's forget that this one says 6x plus 1. Imagine that never even happened. So the angle here, BCD, is a right angle. So if I add those two angles together, I should get 90 degrees. So I can say that 5x plus 1 plus 6x plus 1 is 90. Now, before I do anything else, I'm going to combine like terms. So I've got 11x plus 2 is 90. Now I want to get x alone, so I'll subtract 2 first. We get 11x equals 88. And divide by 11, and I get x is 8. We just have to use what we know about how a rectangle works to make assumptions about what we're given. Let's keep moving on. Here's a proof for us. We're given EFGH is a rectangle. We want to prove that triangle EHG is congruent to triangle FGH. So I'm going to put EF, just kidding. Let's get, oh, too far. Here we go. Let's say that EFGH is a rectangle. That's given. Well, now we are going to state something really obvious, that EFGH is a parallelogram. And we can do that because it's the definition of a rectangle, right? In the very first sentence on this page, it says rectangle is a parallelogram. Now we can say that because it's a parallelogram, that side EH is congruent to side FG, because in a parallelogram, opposite sides are congruent. I'm going to use this for a congruent symbol because that's what it is. We can also say that side HG is congruent to line HG because of the reflexive property. If we're saying a line is equal to itself and is present in two triangles, we always use the reflexive property. Holy moly. Now, let's see what else we need. We have EH and FG are parallel. We have HG is parallel to HG. Now we know, or congruent to HG, so sorry. Now we want to say that segment EG is congruent to segment FH. And we can do that because it's the definition of a triangle. So we can say that EG is congruent to, oh, I said triangle, it's definition of a rectangle, FH, holy moly, because in a rectangle, our diagonals are congruent. Rectangle. Last but not least, we can say that triangle EHG is congruent to triangle FGH, and you'll see we've got 1, 2, 3 sides, so it's the side congruence. All right, we use the things we know about a rectangle. We know rectangles are a rectangle. A rectangle is a parallelogram. When we have a parallelogram, our opposite sides are congruent and parallel. That if two sides of a triangle are the same, that they're the same side, and that the diagonals in a rectangle are congruent. Let's flip your paper over and look some more at rectangles. We want to determine whether ABCD is a rectangle using different strategies. Well, let's first use slope to find this out. Graph our points first. Yeah. So A is -3, 0. B is -2, 3. C is 4, 1. And D is 3, -2. Connect the dots here. Oh, goodness. This is harder than you would expect on a tablet. There we go. So now we want the slope. Let's find the slope of parallel lines first. So we know that AB is going to be parallel to CD. So let's first find the slope of segment AB, and that is equal to 3 minus 0 over -2 minus -3, which is 3 over 1, which is also known as 3. Let's do the measure of the slope of segment CD. That is -2 minus 1 over 3 minus 4. So that's -3 over -1, which is +3. So we know AB and CD are parallel. Let's look at the other two parallel lines. The slope of segment BC is 1 minus 3 over 4 minus -2. That's -2 over 6, or -1/3. And then the slope of segment DA is -2 minus 0 over 3 minus -3. That's -2 over 6, which is also -1/3. So that tells us that ABCD is a rectangle because slopes are, you didn't even notice, one slope is +3, one's -1/3. If the slope is a opposite inverse, they are perpendicular lines. So ABCD is a rectangle because slopes are negative reciprocals. That means they are perpendicular. If we go on to midpoint and distance, we need to see now not about the midpoint or distance of the sides, but the midpoint and distance of the diagonals. So we need the midpoint of segment AC. So the x component, we add the x's together. So 4 minus 3 and divide it by 2. We add the y's together, 0 plus 1, divide by 2. So that simplifies to 4 minus 3 is 1. 1/2 is our midpoint. The midpoint for segment BD is going to be -2 plus 3 over 2 and 3 minus 2 over 2. So that is 1/2, 1/2. So midpoints of those diagonals are the same. Let's find the distance, the length of segment AC. I didn't mean to put an equals there, so sorry about that. Length of segment AC. We'll use the square root here, the distance formula, the difference in the x's, -3 minus 4 squared, plus the difference in the y's squared. So that's the square root of -3 minus 4 is -7 squared, and -1 squared. That's the square root of 50. So we can leave it like that. That's as good as we need it to be. And the distance between, or the length of segment A, nope, we just did A, BD. That's the square root. Find the difference in the x's. So -2 minus 3 squared plus 3 plus 2 squared. That's the square root of 25 plus 25, and that's the square root of 50 as well. So this tells us ABCD is a rectangle because the diagonals have the same midpoint and length. So we used slope, midpoint, and distance. We're going to do the same thing again. I would suggest you pause here and try the rest of this on your own and then come back and check your work. Let's plot these points first. A is -1, -1. B is 0, -3. C is 4, -1. Oh, didn't mean to draw that. Oh well. And D is 3, 1. All right. Let's see what we know about the slope. We want to find the slope of opposite lines. Oh, nope, just kidding. Well, yeah, we do. Lord. All right, so the slope of segment AB is -3 plus 1 over 0 plus 1. That is -2 over 1, so it's -2. Let's do the slope of segment DC, and that is 1 plus 1 over 3 minus 4, which is 2 over -1, which is -2. Other lines. Let's do the slope of segment AD. That's 1 plus 1 over 3 plus 1. That's 2 over 4, so it's 1/2. And the slope of segment BC is -1 plus 3 over 4 minus 0. So that's 2 over 4, which is 1/2. So we can say ABCD is a rectangle because slopes are negative reciprocals. Let's do the same idea that we did before with midpoint and distance of our diagonals. That one's awful. So the midpoint of segment BD is going to be 3 plus 0 over 2 and 1 minus 3 over 2. So that is 3/2 and -1. The midpoint of segment AC is going to be -1 plus 4 over 2 and -1 minus 1 over 2. So that's 3/2 and -1. Now, we need the distance, the length of segment BD, square root of the difference in the x's, 0 minus 3 squared plus difference in the y's. It's the square root of 9 plus 16. That's the square root of 25, which is just 5. The length of segment AC done in the same way. I don't know why I'm equals sign happy today. Whew. So difference in the x's, 4 plus 1 squared plus -1 minus 1 squared. So that's going to be, -1 minus -1. So that's going to be the square root of 25 plus 0, and that's 5. So ABCD is a rectangle because the diagonals have the same, samed, whatever that means, midpoint and length. It's a lot of work, I know, but I really hope that you were able to follow along. I hope you please reach out if you have any questions. I'm happy to help, and I really hope I get to see you soon.